In this lecture, we discuss the solution of an important problem of bivariate probability distribution. And it says that if x and y are independent binomial variate, the first one is n1p and second one is n2p respectively. Then their sum, which is u, this is x plus y, is also a binomial n1 plus n2 p variate. Okay, and we use here binomial distribution. So we write already what is binomial distribution. Binomial distribution, if x is binomial np, then the PMF, we know that x is discrete for the variable binomial, and the PMF fx, this is given by ncx p to the power x q to the power n minus x, where the spectrum of x or the range of x is from 0, 1 to n, and p plus q, this is equal to 1 and otherwise is 0. Okay, so we write here two PMF. The first one is fxx, this is marginal PMF of x, which is given by ncx p to the power x and q to the power n minus x. But it is given that x is n1p, so we write n1 and also n1 in place of n. Okay, where x, this is equal to 0, 1 to n1, and p plus q, obviously this is equal to 1, and 0 elsewhere. Similarly, since y is n2p, so we write fyy is given by n2cy p to the power y q to the power n2 minus y, right? And this is y runs from 0, 1 to n2, and p plus q, this is equal to 1, and this is 0 elsewhere. Okay, now here it is also said that x and y are independent, and we already write the, if x and y are independent, then joint PMF is given by fxy, which is defined by probability of x equal to x and y equal to y. This is the definition of joint PMF, and which is given by fxx into fyy. That is the PMF of x into PMF of y. So we write joint PMF of xy is fxy, which is fxx into fyy. That is, we write n1cx into n2cy. We write n1cx and n2cy into p to the power x plus y, because here p to the power x into p to the power y, we directly use the rule of multiplication, and q to the power n1 plus n2 minus x plus y. Okay, this is the joint PMF fxy, and the ranges are x equal to 0, 1 to n1, and y equal to 0, 1 to n2. Okay, and 0 elsewhere. Now we have to find out the distribution of u. Okay, here u, this is equal to x plus y. Now the PMF of u is given by GU. This is given by probability of u equal to u, right? And we put the value of u, this is a random variable, so we get probability of x plus y, this is equal to u. Okay, this is the required PMF we have to find, and it is proved that binomial n1 plus n2 p period we have to prove it. Now this probability can be written as this is summation probability of x equal to x and capital Y equal to small y, where small x plus small y this is equal to u. If we take x plus y this is equal to u, at that type of probability we get this event or probability of this event. Okay, and we already says here this is nothing but this is x plus y this is equal to u into this is f of xy. Okay, and what is fxy? In this case fxy means this, or we write this period, this period. So we get and write here this is summation x plus y this is equal to u. We put the value of fxy, which is given by n1 cx into n2 cy p to the power x plus y into q to the power n1 plus n2 minus x plus y. Okay, now we put the value of x plus y this is equal to u here. So we get the term this is summation x plus y equal to u. This is n1 cx, this is n2 c, this is n2 cy, this is p to the power u, this is q to the power n1 plus n2 minus u. Okay, we get this result. This is minus u. Clear? Now these two terms p to the power u and q to the power n1 plus n2 minus u, this is independent of x and y. So we write gu as PMF of u is gu, which is given by, we write this result here, this is p to the power u, this is q to the power n1 plus n2 minus u, and this is summation x plus y this is equal to u into n1 c x into n2 c y. We get this result. Okay, now we have to find the value of this function by using an identity, and before going to taking the identity we name this relation as relation number 1. Now we consider the identity like 1 plus t whole to the power n1 plus n2, and this is equal to 1 plus t whole to the power n1 into 1 plus t whole to the power n2 to prove or to find out the value of this function. Okay, and if we expand both sides in binomial expansion, then we get n1 plus n2 c0 plus n1 plus n2 c1 into t plus n1 plus n2 c2 into t square, and so on. We get n1 plus n2 cu into t to the power u, and so on we write. And in the right side we first find, or we first expand this expansion. This is n1 c0 plus n2 c1 into t plus this is also n1, and this is n1 c2 into t square to n1 cx into t to the power x, and so on. And another quantity is n2 c0 plus n2 c1 into t plus n2 c2 into t square to n2 cy into t to the power y plus, and so on. Okay, now if we equate from both sides the coefficient of t to the power u. Okay, so here we write we equate, or we write here equating equating the coefficient of t to the power u from both sides, we get the result as, from left side we get t to the power u, the coefficient of t to the power u is this. So n1 plus n2 cu from the left side, and from the right side there are several number of t to the power u is present. Okay, and how to equate the coefficient with the left side? So this is, we write summation x plus y, this is equal to u, and from here we get n1 cx, this is t to the power x, and if we take or we multiply this term with this term, then we get t to the power x plus y. Okay, and so the coefficient is n2 cy. So this is the coefficient of t to the power x plus y, and we get those term or those coefficient of the term where x plus y is u. So this is the sum of the coefficient of t to the power u, and this is only one. Here is present the coefficient of t to the power u. Okay, and we name this relation is relation number 2. And clearly the right hand side of relation number 2 is nothing but this term of 1. Okay, so PMF of u is given by GU, which can be written in the form, we write this term first because this is n1 plus n2 cu, this is p to the power u, this is q to the power n1 plus n2 minus u. Okay, and since we know that u, this is x plus y, and the ranges of x and y are both 0, 1 to n, so we must write here u, this is also 0, 1, 2 to n. And clearly if we compare this PMF with the PMF of x, and we say that this is NP variate, binomial NP variate, so clearly from this relation we say that, u is binomial n1 plus n2 p variate. Okay, because here it is given that n1 plus n2 in place of n, here also n1 plus n2 in place of n, and here the variable is u, so u, that is x plus y, is binomial n1 plus n2 p variate. Very, very interesting and important problem from two-dimensional distribution. Right? Thank you for watching.